Remember that by definition, log base a of b equals c is the same as a to the power of c equals b. In other words, a logarithm is an exponent that you need to raise your base into to get the number inside of the log. Logarithms have a few very important properties. Let's look at these formulas that represent the properties of logarithms. Property number 1. If you have a log of some base a, and inside of that log you have two numbers that are being multiplied by each other, b times c, it can be written as a sum of two separate logs, log base a of b plus log base a of c. Here are a few examples of this property. Log base 9 of 9 times 81. This is how you can expand this logarithm. Because inside of the log you have two numbers that are being multiplied by each other, you can represent this as the sum of two separate logs, log base 9 of 9 and log base 9 of 81. Before I continue with this question, look at the second to last property, log base a of a equals 1. What this means is that log of any base of the number that matches the base is always equal to 1. Returning to our question, we have log base 9 of 9, which is 1, and then log base 9 of 81. To simplify the second logarithm, ask yourself, 9 to what power is 81? The answer is 2. So you're left with 1 plus 2, which is 3. Here is another example of expanding logarithms ln of xy. Using the exact same property, this will expand to ln x plus ln y. Now let's go back to the list of the properties and look at the second one. It's very similar to the first one, but instead of dealing with the product inside the log, it deals with the quotient inside of the log. If you have two numbers inside of the log that are being divided by each other, this log can be expanded into the difference of two logs. Here is an example. Log base b of q over 7. Using the second property, we can write it as log base b of q minus log base b of 7, and you're done. Now let's look at the third property. Log base a of b to the power of c is c times log base a of b. This property suggests that you're allowed to pull the exponent from the number inside of the log to the front of the log. For example, log base p of z to the power of 11 is the same as 11 log base p of z. Here is another one. ln of the fourth root of 2. Keep in mind that ln has the base of e. Also remember that fourth root of 2 is nothing but the exponent, so this can be written as ln of 2 to the power of 1/4. Now, going back to the property, we're allowed to pull that exponent to the front, so the final version is 1/4 ln of 2. The next question will ask you to combine all three of these properties together. Here we go. Log base b of p to the power of 4 times q to the power of 7 all over m to the power of 4 b to the power of 8. These numbers, because they're at the top, will get a positive sign in front of the log, and these will get a negative sign based on the second property. So here we get log base b of p to the power of 4 q to the power of 7 minus log base b of m to the power of 4 b to the power of 8. Remember, the minus sign in front of the second log is based on the fact that you have a quotient inside of the original logarithm. Each of the new logs has a product inside of it, here and here. The products inside the logs can be written as sums of two separate logs. As we are expanding even further, keep in mind that the entire second log has the minus sign in front of it. So here's what we have: log base b of p to the power of 4 plus log base b of q to the power of 7 minus log base b of m to the power of 4 minus log base b of b to the power of 8. Finally, using this third property, I am allowed to take each of the exponents to the front of the logs, which means now I have 4, that used to be an exponent, log base b of p, plus 7, which also used to be an exponent, log base b of q, minus 4 log base b of m, minus 8 log base b of b. Log base b of b is equal to 1. So when you multiply this 1 by the 8 that's in front of it, you will have an 8. Here is the final answer. Here is another similar example: log base 10 of the square root b to the power of 5c. Remember that the square root can be written as the power of 1/2. So here we have log of b to the power of 5c, the whole thing to the power of 1/2. Remember that 1/2 affects both the b to the power of 5 and the c. That means inside the log we have b to the power of 5 over 2 times c to the power of 1/2. Now I will write this logarithm as a sum of two separate logs: log base 10 of b to the power of 5 over 2 plus log base 10 of c to the power of 1/2. 5 over 2, because it was an exponent, can go outside of the log base 10 of b. 1/2, because it's an exponent, can go outside of log base 10 of c. And now this is your final answer. The next question will ask you to perform the opposite operation, meaning you will have several different logs that are either added or subtracted to each other, and you need to write it as a single log using the three properties we just looked at. In other words, condense 3 logs into one single log. We will start by applying the third property and making coefficients of logs into exponents of numbers inside of the logs. So the first log is now log base b of x to the power of 1/3. The second log is log base b of y to the power of 4. Finally, the third log is log base b of x to the power of 3. Keep in mind that by the first property, addition of logs can be written as one log of a product, and subtraction of two logs can be written as the quotient. So x to the power of 1/3 and y to the power of 4 will be multiplied inside of the log, and then whole thing will be divided by x to the power of 3 inside of that same log. The only thing that I would change now is I would write x to the power of 1/3 as cubed root of x. After that, the answer is final. Log base b of cubed root of x, y to the power of 4 divided by x to the power of 3. There is one more property we haven't looked at yet, and that's property number 4. A to the power of log base a of b is b. Let's look at an example. Here you have 4 to the power of log base 4 of 5x plus 3. Based on the fourth property, 4 to the power of log base 4 kind of cancel each other out, leaving you with 5x plus 3. Very similarly, 2 to the power of log base 2 of 15 will equal to 15 because 2 and log base 2 kind of cancel each other out. Finally, let's look at the very last property, log base a of a to the power of b that's equal to b. If you think of it, this property comes from property number 3, where you're allowed to pull the exponent to the front, and also property number 5, which says that log base a of a is 1. Look at the very last line here. If you use the third property and pull b to the front, that will result in b times log base a of a. But you know that log base a of a is 1, leaving you with b.